All right, biology kids, this is going to be your first video for your Chapter 7 notes. This chapter is on complex inheritance patterns, and it can actually be fairly difficult. I'm going to try to break up these videos into smaller chunks so that you can watch it and rewatch it if you need to, so that you can understand what's going on with each successive thing that we do. Your objectives for this first section are to relate dominant recessive patterns of inheritance in autosomal chromosomes to genetic disorders. So we're going to talk about genetic disorders, some of which will be recessive traits, some of them will be dominant traits, and the way they get passed on from one generation to the next obviously would be different then. We're also going to talk about inheritance and sex-linked traits in this section, but I'm going to do that in a different video again so that you can break this up a little bit and rewatch if you need to. Now, first off, we need to recall that all of Mendel's observations from last chapter were talking about genes that are located on autosomes. Remember, you have 2 copies of each autosome, one from mom, one from dad, which means you're going to have 2 alleles for every gene. Now, what we're going to be doing here is talking about different kinds of disorders. Some of them are going to be recessive, some of them are going to be dominant. But the terms that we use and how we're going to interpret these Punnett squares that we do are going to be different depending on which one you're doing. So make sure that you understand that these 2 squares that I'm going to do on this slide are different, and know the difference and understand when which one applies. Right, so first off, we're going to talk about a recessive disorder. Right? Obviously, in order to actually express that recessive allele, you have to have 2 of those alleles. All right, so we're going to talk about a cross between 2 parents, each of which is going to be carrying that trait, carrying that disorder. So both of my parents are going to be heterozygous. So that would mean that they have one big, one small, right? One dominant, one recessive allele. So this would be a monohybrid cross from last chapter. And we're going to look at the possible outcomes for their offspring. So you fill in your Punnett square, and you get these 4 different combinations. Now, the one big key for recessive disorders, those recessive traits, we have this term here down at the bottom where you have carriers, right? People who are carriers have the trait, they have the allele, but they don't express it. So you may have that allele and you can pass it on to your offspring, but you yourself are not affected by the disorder. So mom and dad in this example here are both carriers. They have that recessive allele, that lowercase d, that could lead to that disorder when it's all said and done. When you look at the possible offspring though, right, you get all those different combinations. It's still going to be those same patterns that we saw before. But when you're looking at these offspring, these 2 are going to be carriers. They can possibly pass that on to the next trait. This individual is free and clear, does not carry that trait, and will not possibly pass it on to his offspring or her offspring. But this last one here has 2 recessive alleles and will show that trait. So if 2 parents are carriers for a recessive disorder, there's a 1 in 4 chance that their offspring will have that disorder, right? And this is one of those things that we kind of want to know about because we don't want to pass that on to the next generation if it's at all possible, right? It's a disorder because it's not a good thing. So in this case, you have a 1 in 4 chance of having offspring that have that disorder. These 2 parents, given genetic screening, may choose not to have offspring if that was the case. Right? But this is for recessive disorders. This example is for a recessive disorder. It'd be completely different if this was a dominant trait. I can take the exact same 2 parents with the same look. They're not the same parents. But be dealing with a different trait a different disorder, this time being a dominant disorder. You still do your same crosses and you get the same outcomes, but the way you interpret those outcomes is a little bit different. Now in this case, since I had a monohybrid cross again, both of these parents are affected by this disorder. They both have the disorder, right? So this is not necessarily a common case, but this is just how we're going to read this specific version. So both parents have the disorder, but what's the probability of their offspring having that disorder? So remember, in order to show a dominant trait, all you need is one dominant allele. So every one of these three offspring is going to show that trait. They're going to express that disorder. They're going to have that disorder. Whereas there's the one offspring down in the corner, that 1 in 4 chance that they might be free and clear and not have that disorder. Right? Notice the big difference between the dominant version on the right and the recessive version on the left is that there's no such thing as a carrier in a dominant disorder. If that's a dominant trait, there's no such thing as a carrier, because in order to be a carrier, you carry it, but you don't show it. Every individual that has a capital D on the right is expressing that trait. So there's no carriers, you just either have it or you don't. Whereas on the left with the recessive example, you could be a carrier and still not have the disorder, but you'd still be in danger of passing that on to the next generation. Right? Only one individual was affected in four, but 2 of the other 3 could possibly pass it on to the next generation.